Alrighty, having a look here guys, success criteria C, looking at constructing a scale drawing. Question below here wants us to look at taking this figure here, okay, and enlarging it by a scale factor of 2 about point P. So from point P, we want to go and enlarge it by a scale factor of 2. Okay, scale factor of 2 would mean that any measurement we take from this shape, we double it or multiply it by 2. So at the moment, point A and point P, they're in the same spot. Okay, they're right here. So as point P is point A, if we were to double that, it would remain in the same spot. So point A is going to remain where it is. We can see point B here is 1, 2, 3, 4 units away from point P. Now if we were to double it or apply a scale factor of 2, we would be looking at taking that point B, at the moment it's 4 points away, we are now going to take it double that, and we're going to move that out to here. Okay, let's look straight down to point D now. At the moment it's 1, 2 units away. If we were to double that, we would be looking at taking it 4 units away from point P. So we're doubling where it goes, okay? And we would have a new point D there. If we were to look at point C, at the moment, and you would use a ruler for this, but you are looking at a certain measurement from point P to C, and whatever that measurement is, you are then going to go and double that, and it would get out to here somewhere, okay? So what we've got now is we've got this situation, nice thick line, where that we now need to join up the points, just so you can see it, so that this new shape has actually been enlarged by a scale factor of 2, meaning that every measurement from point P out to point B to point C and to point D has been doubled, and we now have a new point B has been doubled, we now have a new point C has been doubled, and we now have a new point D. The only one that stays the same is point A, because point A shares the same spot as point P. As we scroll down, we've got another example. We're going to enlarge by a scale factor, let's go 2 again, and let's see how this is different, because at the moment we've got point P and point A in 2 different spots. Okay, so as none of our original points on our figure share point P, the same space as point P, that means they're all going to move. So let's go and investigate how that's going to look. At the moment, point A we can see is 1 unit away from point P. Now if we were to double that, point A would now move 2 units away. Okay, point B, so from point P to B is 5 units distance. We would now look at taking that doubly as far and going out to a spot that would be 10 units from point P. Okay, we look down here to point D, and again you guys will use a ruler. So say that measurement there was 3 centimeters, you would now draw point P along that same line. You would now draw that 6 centimeters away, and it would come down here somewhere. All right, now as it is, you can see basically where our shape is starting to take place. This would be the top part of our figure. We come down and join up to here, okay? Then we go back and we just need to finish off that last one. Again, you guys having a ruler will be able to measure the distance from point P to point C, and then go and double that, and it would come down to here somewhere. All right, so now we can finish off joining these up, and we now have our enlarged image from point P, which looks a little different from that first one, purely because that point A and that point B are not shared spaces at the moment. They're in different parts, so that means every point on the new figure, okay, the orange one, will have moved.